I'm going to go a bit more technical into the L1 network and all the components that it has. First, an overview of the L1 network, the L1 node orchestrator, and finally a bonus, which is the SCRN NPM package for Saturn. So the L1 network is a decentralized server-backed Web 2.5 CDN. Web 2.5? Because it still runs on a lot of Web 2 tech, not completely 3, but hopefully it does serve both Web 2 and Web 3. Some stats about the L1 network as of today morning. There are 66 nodes worldwide. Here's the map. Most of them are in the United States and North America. You can see that we're lacking a lot in APAC, Asia, Africa. So if you do have nodes there, we would love for you to join. The L1 network is ultra fast. It's 2.9 times faster than the IPFS gateway in the median. On average, it's 1.8 faster with under 400 milliseconds response time. On the 95th percentile, all the requests take under 1.1 seconds. And for the fastest internet or users in the world, that's the 5%, it's under 20 milliseconds. And that's 5 times faster than the IPFS gateway. And we just saw that with Sydney. That was incredible. On traffic, right now we have over 2,000 requests per second, 181 million requests per day, and we serve over 80 terabytes of data per day. In terms of reliability, we have a 99% cache hit ratio because we're over-provisioned with capacity. So we would love for you to abuse Saturn and just squeeze it. Zero downtime auto updates that roll into the network for an hour or so, and under 0.6 error rate, which is 70% less than the IPFS gateway. And over a lot of iterations, we got a A+ Qualys SSL Labs rating in terms of security. So how do we access the L1 network? Retrieval clients discover it through DNS. We're using Bunny DNS for this geolocation routing. And just through HTTP, you can request any SID content that you want. We use strn.pl as the main domain for the main network, Saturn network, and Saturn-test.network, which utilizes the test network. It has fewer nodes with fewer capacity, but it's always there for us to run tests and experiments. Right now, we support HTTP 1.1 and HTTP 2 with TLS 1.2 and 1.3. That's 99% of all the internet clients. We do not support unencrypted HTTP, and it's a drop-in replacement for the IPFS.io gateway. Just switch the domain, and you get the benefits of Saturn. In terms of the network, we're looking into the connecting with L2s and L3s for cache missing, routing over HTTPS for the smart clients that can run some logic in JS or Rust or Go, meaning, and we'll see this in a bit, IPv6 support. Right now, the nodes can only be discovered for their IPv4 address. HTTP 3, which is going to be huge to improve the time to first byte. We've run some experiments with Nginx, HA Proxy, and Caddy to compare them all, because we use Nginx under the node. We did some experiments with Nginx Quick, which is in the done by the Nginx team, and Quish by Cloudflare. Also running boring SSL and quick TLS, but it's just not ready yet, and it impacted time to first byte. So we decided to remove HTTP 3 for now. And it's also, we want it to be super private so that not even us can see what traffic from which IPs saw that. So we're going to double hash the IPs from the L1s and the clients directly. Onto the L1 node. The L1 node just has one task, which is serve verifiable content address car files. Some basics, it's a Docker container, as Ansgar already mentioned. It's super easy to set up. It takes about 15 minutes. It can be done through bash, just bash commands, or Ansible. It has only two inputs, your Phil wallet address and an email, so that we can send you notifications in case anything goes wrong. And there are two main components, the Nginx reverse proxying and caching component, and Node.js for the cache miss back to the IPFS gateway, and some logic. Overall architecture of the L1, we see Nginx and Node.js being the two biggest components, but we also have the log ingester, which just sends the logs of who retrieved what and at what times. To the log service, there's the registration component, which is, hey, I just joined the network, please send me some traffic and add my IP to the DNS of the strn.pl domain. Two endpoints that the Node.js service has is just the registration check and the health check to make sure that your node is still running healthy and that it can serve seeds. We also have outside of the Docker container the auth updater, which is just a bash script, and it runs smoothly after so many tries. The current requirements for running an L1 is just a Linux server with IPv4 address, two ports, the main HTTP and HTTPS free, Docker installed, CPU of 6 cores, 10 gigabits, as Ansgar mentioned. Hopefully, it will go down. 32 gigabytes of RAM and a terabyte of SSD storage. You can see, hopefully, we'll lower those, and so you can. This is the source of truth for those requirements. And hopefully, we will lower them. We got Nginx to be super fast thanks to these technologies. Enabling testing them, experimenting with them. If you're interested, please reach out to me. If you want to improve your own Nginx setup, I'm happy to help you do that. In terms of the L1 node, what we want to do go next is just improve the operator experience, making it easier to set up and allowing more customization, because that's the most feedback we have received from the early operators. They want more customization. So we're going to give you that. And lower requirements, because the more we can smartly route all the users around the world to the fewer L1 nodes, the lower requirements we can give. Now, the Orchestrator, which is the magic behind the scenes. It handles node registration, geolocation, TLS certificate management, DNS, health checks, stats collection, and it provides live stats. So the geolocation is performed always upon registration of a new L1 node. We use IP info. It allows DNS geo-routing and the mapping of the nodes worldwide, as we saw. And it's what pretty much allows to discover where in the world we need more L1 nodes and where operators could get more field to serve traffic in those regions. On terms of TLS management, every node has a key and a certificate for strn.pl. And in case they go bad or they just go fraudulent, we revoke their certificate and remove them from DNS. And that's the end for them. They don't earn any more field. It's provided upon the registration, and they are 90-day certificates that are renewed just 2 days before expiration. Under the hood, we use 0SSL. Keys are elliptic curve. We use SHA-384, and we have DNS CAA. So that's how a lot of things that got the rating on SSL Labs up. For DNS, we use Bunny DNS under the smart routing, but we want to switch off DNS with routing through HTTP. Because there's something flawed about DNS. Like if you have the DNS extension where the client subnet is sent to the resolver, we can get you pretty close, but not always. And if that's not the case where you send your client subnet, then you go to the closest pub of Bunny, which is 36 pubs worldwide, and the last hop address is what's allowing the routing to happen. And we've seen a bunch of cases where Toronto user gets routed to New York or Atlanta, given that there's a Toronto node. DNS gets updated for each node on the registration, and the registration happens every 5 minutes or so, and the record gets removed if they go down or they deregister. And why might they deregister? Because they are updating the software. Or they just want to retard the L1 network without getting slashed on their earnings. The DNS for each node is based on a lot of things, mostly performance, the time to first byte, but it's also in terms of capacity. If you have 100 gigabytes of uplink, we want to give you more traffic than one that has only 25. And initially, when you set up an L1 node, you're going to get very low traffic and incrementally increase as your cache gets filled. The orchestrator also does health checks every minute, just checking that the Nginx service and the shim, Node.js shim, it's also responding. It tracks the time to first byte and the download time of a test set. And if you're down, it just removes you from the DNS and impacts your wait for up to 24 hours. It does some stats collection, aggregated stats. So it tracks the time to first byte for the past hour every 5 minutes, and for the past day every hour. It also receives upon every registration your CPU, your memory, and your disk, and bandwidth metrics on the interface, the NIC. If you go to that website, orchestrator.strn.pl, you can see live stats on how many nodes are actually live right now. You can also get the map of where they are, and some nice stats that Ansgar already showed, containing everything that you would want to see about those nodes. In the future, we want the orchestrator to be globally distributed. This allows for just better routing in terms for both DNS and non-DNS with the eventuality of routing over HTTPS. Node operator notifications, in case they go down, they are running an older version, the smarter routing, and just better UX, operator experience, and developer experience and integration. Lastly, the SCRN NPM package, which is just the easiest way to get started in Node.js and JavaScript. It allows you to install it as if it was fetch and just retrieve content sits from Saturn super easily. It gives you the HTTP response if it got to verify the content, and then you can do anything you want with it as you would normally do with IPFS. It also reports the stats of how long it took to download from Saturn to the lock ingester, the node which gave the content to you. And we track all of this to be able to match with the nodes logs so we can pay them. How to get involved? Run your own L1 node and earn fill. Use Saturn for your retrievals and work with us. We have open roles in the team and the company. You can reach out to us in the Filecoin Saturn channel in Filecoin Slack, and me on the internet with Diego or Baquero. Thank you.
Yeah, my question is, so is Nginx caching files, or is it caching blocks? Meaning that if I request, for example, a car file, can I, and then I do another request, but for a file, a specific file that's that car file, would it be a cache hit or a cache miss in that situation?
Right now, it would be a cache miss.
And so how do we make it a cache hit with Nginx in that situation, or in the future? What would be the plan to do?
So we're not caching complete car files and then unpacking them as needed from the shim. That's an ideal that we would love to have. But the way that Nginx caches things by their URI, it's not possible right now. But what we could do is go back from the shim back to Nginx to get the car file again, unpack it, and give you what you want. We just haven't built that yet. But we've thought about it.
I'm just wondering, what is the caching strategy in terms of like geolocation? You mentioned they were all over provisioned. Are you prefetching all of an IPFS gateway content, or how do you plan to scale that in the future and get feedback to improve the caching? I'm assuming that will lead to better performance, but curious your thoughts on the future there.
So the caching strategy right now is a default for Nginx, which is just cache on first hit. And because of the provisioning of the L1 nodes that we did and the Saturn Sunrise program operators, which have over 1 terabyte of data, we just haven't seen that much data. We have thought about caching on second hit or just different strategies based on performance and usage. But we have not reached that point, so we will ask those questions and challenges whenever we hit them. But for now, I don't have a better answer.
What was the design choice to go with DNS and not other technologies for the orchestrator?
What do you mean?
There are other ways to find the L1 node maybe than a central DNS?
Oh, right, because we want to enable like just the quickest way to get up to speed, which is replacing IPFS.io with Saturn.pl, and the only way to do that is with DNS. That's why second largest performance improvement would be not to route by DNS, because it's not perfect, it's far from perfect, and really get the clients like a list of nodes in your own region and then test against them. But that's an optimistically upgrade. Because you first do DNS, like we want you to have the content as fast as possible. And then we upgrade you to routing through HTTPS, which has already tested latency against your closest nodes. And that's only for the smart clients. But if you use curl from the CLI, then you're out. You have to use DNS. That's why it's a Web 2.5 CDN.